Alright, today is October the 9th, 2015, and we're watching the Northeast Pacific Rainbow Infrared Loop. And today in Los Angeles, we had 102-degree weather today, and we had much lower humidity. This morning, the relative humidity was around 29%. Right now, it's 25%. So it's dried out quite a bit. The soaking we got a couple of days ago, we got a half-inch of rain in a pretty short order, and so that soaked the ground. But now that moisture in the ground has pretty much evaporated. There are certain spots that are still a little bit damp, but things have dried out pretty much. We had heavy chemtrailing all day today, starting at midnight. I was up well into the early morning hours last night. And Los Angeles was just having a chemtrail storm last night, all throughout the entire evening, well into the evening until about 3 o'clock in the morning is when I finally went to bed. A lot of chemtrails this morning when I got up. The skies were partially cleared. I use that term lightly. The sky was a pale blue, but most of the chemtrailing today was done in the early morning hours. All right, so we can see the result of all that effort here. We have most of California looks very dry. It's that purple, that sort of magenta and purple down here on the scale on the far left of this scale. That indicates the dryness factor here on this scale. All right, so they've dried out this area very effectively with that high pressure. They parked a HARP transmitter right out here over the west, and that is blocking all this moisture here. We had that Hurricane Oho join up with another low pressure up here in the Gulf of Alaska, and that generated some very severe weather, which is indicated over here, right here. You can take a look at this right now. We've got a developing storm here. We have a storm here and a gale up here, a 962 millibar low pressure right here, and a 971 millibar low right here, all up near Alaska, right up in this area. So there's a lot of really stormy weather up in this area. Okay, so that is the reason why these people have put a high pressure in place right over the southwest to block all of that weather. So here's California. You can see the effect that high generated. Now down here, this is that low pressure that is moved slightly further south. It's actually moving out to sea right now, and this low has a HARP transmitter on top of it, and I'll show you that right here in the this is the water vapor loop. Okay, and we can see the effect that this high pressure, they're following this thing, and they've got it throttled back with a high pressure downburst right here, and look at the effect that that's having here on this moisture field right here. It's just pushing it away. So that's some pretty good evidence of the pressure that they're applying to keep this system from developing into a hurricane as it moves out into the open Pacific Ocean. All right, now down here we have, this here is Tropical Storm Nora. All right, let's get Nora on the picture. Right here, Nora is just a tropical storm right now with 40-mile-per-hour winds. Okay, with a core pressure of 1,006 millibar, and that storm is moving due west at 16 miles per hour. Okay, we can't see any of that very well for some reason. Let's go ahead and look at the cone track here. So this is forecast to move basically due west until about Monday, when it takes a turn on Tuesday and then backtracks to the northeast by Wednesday. All right, so this ought to be interesting. Let's go back and look at the big map again. and see what's happening here. Okay, so we have this storm, or rather this upper level low moving back out to sea. And what the people on TV are saying is that this storm, or rather this low, will move out to sea and then double back up towards California and bring some rain. And that's their forecast. But what they're going to do is, you can see what's happening here. They're building a high pressure right here, and they don't want this storm here, this tropical storm, getting mixed up with this low pressure right here. So they're going to keep a big area built in around this upper level low right here, this vortex moving out to sea. Okay, so this thing is moving pretty fast. This storm here is moving about 14 or 15 miles per hour. And so we'll keep an eye on all that. Hawaii's in the clear as usual. And we do have a jet stream right here that's moving all this moisture right back up into the Yucatan area, right up in this area, up into Canada. A lot of severe weather up there. Let's take a look at this in the infrared loop. Okay. All right, here's the western U.S. We can really see this jet stream flow right through here. And there's a lot of chemtrails all through here. We had a lot of chemtrails today and yesterday and the day before. Let's look at this in the rainbow loop. You can see the severity of this rain is very, very intense. That's a lot of heavy rain right there. It's probably generating some snow up there in the northern latitudes. That's all up there in Canada, Alberta, and different provinces. All right, saw that. Here is the this is the 300 millibar. This is a jet stream map. You can see what's happening. This flow is coming right out of the Bering Sea and then turning up towards Canada. And we have a high pressure indicated here. And then we have this low right down here. So some of this could get spun off. Some of this flow here could spin up, but they have such strong high pressure here that that's all that is unlikely. What's going to be interesting to see is what this low ends up doing here. This is supposed to move out and then double back towards California. So that'll be interesting to see. Here is the 500 millibar chart. We've got a high right here, right now. We've got a very, very powerful area of low pressure up here, where all of these, the hurricane merged with an upper level low, and there's a bunch of lows that are all near each other, and that's this area up here, where a lot of very stormy weather. Okay, so this is the East Pacific, and we can see this area of low pressure moving out to sea, and right here with that heart transmitter on it, and we can see the effect that downburst of air, descending air right here, is just moving all of this away from that core, and it's expanding this border. All of this here is being pushed away by this high pressure right here that they're going to maintain on the top of this low pressure as it moves out into open waters. Otherwise, this would develop into a large storm. So that's why they have a transmitter right on top of that. All right. And by the way, this storm here, Nora, I think is what it was. This is being blasted, and we can see the pattern right around the edge there. That storm is being hit with microwave or some method of heating the core, probably microwave. And we can see the blast pattern all the way around. And also on at about the 10 o'clock position on this storm, right here, we can see a very interesting feature right there at the very last frame. Something just flying out of the corner of that storm there. And we see that a lot. When these storms are hit with tremendous amounts of heat so quickly, all that expanding air and water vapor goes shooting out. And we see these features a lot and unfortunately this camera is not very good, so I'm gonna have to let's see if we can refocus the damn thing and get some proper quality out of this thing. Jesus. Come on. Let me adjust the screen here and see if we can get something better. All right, so we have a blast pattern all the way around the edge of the storm, and we have a lot of what appears to be steam, and that is always accompanies a blast pattern. We always see this light-colored leftover of water vapor and steam after they hit the core of these storms. So we're seeing that as well. So we're seeing the blast pattern. We're seeing we are seeing diminishment in the core, and also we're seeing some water vapor shooting out of that one corner there. So that is being hit. We'll keep an eye on that, and let's go take a look here at the. This is the infrared loop for the same view here, and we can see that interesting feature right there at the last frame. Looks like high velocity water vapor just coming right out of the corner of that, along with all this blast evidence. This is a pattern that is indicative of a blast in the center. Very quickly expanding, very quick expanding water vapor. We have water vapor that's heated very fast, generates shock waves and a blast pattern. Okay. Now we have Alaska. that hurricane that merged with the low, all of that, and the jet stream, all of that very turbulent weather, that dangerous weather is all up here. We can see that happening here. So that's all spinning up right into Alaska and part of Canada, right there. Here it is in the infrared loop. That's a lot of heavy rain. You got a center of a low right there spinning. Part of that jet stream flow, pushing that all into Canada. All right, so that's pretty much it. Go ahead and post this, and we'll do an update tomorrow.